Now we're going to do another example. We're going to need our conversion factor. We're going to need our definition of a mole. By definition, a mole is 6.02 times 10 to the 23rd particles. And those particles can be atoms or molecules or formula units. So we're going to need that definition. So let's look at our problem. It says up here, if a donut contains 0.11 moles of sugar, that's our known. It contains 0.11 moles of sugar. How many molecules of sugar are in the donut? Well, we put our known over 1. 0.11 over 1 is unchanged, still 0.11. And we're going to multiply by a conversion factor. And first thing we're going to look at is the unit. Let's bring down moles into the denominator so we get rid of the unit moles. What do we want to be in? Well, we want to be in molecules. How many molecules are present? Okay, go up to our conversion factor. There are 6.02 times 10 to the 23rd little particles or molecules in every 1 mole. So 6.02 times 10 to the 23rd molecules in 1 mole, cancel out moles. And then we just move over here to our calculator and try it on this calculator. So let's go 0.11 times 6.02 times 10. Actually, I'm going to just go back one, and I'm going to use the 10 to the power of button. You might have a 10 to the power button on your calculator that you can use right here. You also might have a 10 and a caret key, a little upside down V. You could type in 10 and then the caret and then 23. You could do the 10 to the button and it puts in the 10 and you just need to put in the 23. You might have an X to the Y or Y to the X button where you can put in 10 and then that button and then 23. So try that on a calculator now. Pause if you need to. We get 6.622 times 10 to the 22nd molecules. And this makes sense because we know we've got less than a mole. We know we've got about 1/10 of a mole. So it makes sense that we've gone down by about a factor of 10. And that's how many molecules of sugar are present in this donut if it contains 0.11 moles of sugar.